Hello, we are continuing the previous video. So the member in the previous video we have seen that at every joint there these are the members DA, DG at joint E, EH, EB at joint F, FI, FC at joint G, GD at joint H, HE at joint I, IF at joint A, AD at joint AD at joint B, BE at joint C, CF. Okay, similarly these are the beams you can see in this diagram. This at joint D, this is the beam DE. At joint E, this is the beam EF. At joint F, beam is FE. The diagram is not visible in this image, so I am going to may draw here a diagram. So I cannot make drawing. So you can see that these are the members. This is the diagram. Every joint at joint G there are only one column and only one beam. At joint H here is two beam and one column. At joint I here is one beam and one column. At joint E here is two column HE and EB and two beam ED and EF. Now okay, so moving to the next step, K is stiffness is I by L. So column first I by L will be I is throughout the frame is only 1, so I will take I is 1 because I is constant throughout the frame, so I is 1. Now at for column DA, stiffness is I by L and the length of DA is 5 meter, so stiffness will be 1 by 5 is 0.2. Now DG, the length of DG is 3.5, so 1 upon 3.5 is 0.286. At E there are two columns EH and EB and the length of EH is 3.5, so 1 upon 3.5 0.286, and EB length of EB is 5 meter, so 1 upon 5 is 0.2. We can see here EB, the beam EB, length of EB is 5 meter, so 1 upon 5 stiffness will be 0.2. And the length of EF, the length of EF is 7.5 meter, so stiffness will be 1 upon 7.5 meter will be 0.133 meter. Similarly we will find out every beam and each column stiffness like 1 by L by doing 1 by L. Now next step is sigma K. The fourth one is sigma K. We will sum out at every joint the stiffness will sum. So at joint D the stiffness is 0.2, so sum is 0.686. At joint E the stiffness 0.286 plus 0.2 plus 0.133 plus 0.2, 0.819. Similarly at point F 0.286 plus 0.2 plus 0.133, which will be 0.772. At joint G, similarly we will sum this at every joint stiffness will be sum out and we will find out sigma K. Now step 5, factors. We will find out factor. As we know, the formula of C is sigma k of beams upon total sigma k. We studied this factor C, which will be the sum of stiffness of all beams at this joint upon sum of all members at this joint. So C will be sum of all beams, stiffness of all beams at joint DA. In member DA, there is only one in DA. There is only one beam DE. So C will be stiffness of DE upon stiffness all member meeting at joint DE. So at joint DE there are three stiffness: DC, DG, DA, and DE. So C will be the stiffness of stiffness of column, stiffness of beam DE, and means 0.2 upon the sum of all these. So 0.2 upon 0.686, which will be 0.29. Similarly, in beam DE, we will find out G. G will be the sum of stiffness of all column on this beam upon stiffness of all members. So at G of for member DE, DE, stiffness of all column. So all column DG and column DA. The sum of these two column stiffness upon total sigma k. So 0.2 plus 0.286 upon 0.686, which will be 0.71. Similarly, we will find out the C and G of all members of all columns and all beams. Okay. Now step 6. Step 6 is C by 2 and G by 2 from far end. So C by 2 and G by 2 from far end. So for example, if we have this beam DE, so C by 2 will be from far end will be the stiffness the factor C of far end in ED. So for we will take DA. So C by 2 of AD will be this 6 column. So for DA, C by 2, C for AD is you can see here 1. So 1 by 2 is 0.5. Similarly for DE, this DE, the C by 2 of far end any ED. So C of ED is ED. Where is ED? Here is ED. So C of ED is 0.59. So 1.59 upon 2 is 0.3. Similarly for DG, so C by 2 of GD is GD, so C upon 2, so 0.659 upon 2.3. So in next step 7, we will add 5 plus 6. So CM, as we know, the formula of CM is C plus C by 2 of far end, or formula of GM is G plus G by 2 of far end. So CM is equal to C is 0.29 plus C by 2 of far end yani 0.5. So 0.29 plus 0.5, 0.79. Similarly 0.71 plus 0.3, 1.01. 0.29 plus 0.3, 0.59. Similarly, add step 5 or 6 in this step 7 to find out step 7. Now moment factor, capital C, which is the formula of capital C is C is equals to Cm into K. K is stiffness and Cm is this. So capital C will be Cm 0.79 into K. K of DA is 0.2, so 0.79 into 0.2, 0.158. Now and capital G is GM into K, so GM is 1.01 and K of this DE member is 0.2, so 1.01 into 0.2 is really 0.202. Similarly, we will find out all the member C and G. Now next step is total column movement, MT. This total column movement we have already find out in the previous step. See, in this step we have for column for above DEF is 140 and for column moment ABC is 740. So we have write down here the total column moment MT. Now in step 10, the column moment MC is equal to MT into C upon sigma C. So we have MT is 740 and C is in this moment factor, and sigma C will be here. You can see that for the top story sigma C is every columns, the sum of capital C of every column C, DE, no, DA and DG and EH and EB, FI and FC. So we add all the factor of C, we will find out sigma C, and for bottom story we will find out sigma C. So put these value of sigma C in this step 10, we will find out capital MC, which will MT into C upon sigma C. Now DFB, distribution factor of beams, it will be G upon sigma G. So here is G and sigma G is capital G, sum of all beams. So here is only one beam and G is 0.202 upon 0.202, which will be 1. Here are in this another joint E, there are two beam 0.19 and 0.132, so 0.19 upon the sum of 0.19 plus 0.132, which will be 0.59, and 0.132 upon the sum of 0.19 plus 0.132, which will be 0.41. Now moment in beam, MC moment in beam will be MC moment in column into distribution factor in beam. So we have MC and we will multiply with this distribution factor DFB. We will find out moment in beams. So MC is 99.4 plus 23.2 into 1, which we will find out, we will get 122.6, and 26.6 plus 114.5 into 0.59 we will get 33.25. Similarly, we will find out moment in every beam. So here we have already find out the moment in column, moment in beam. So this is the factor method.